So you do not need to write these graphs down to start with. This is what we did last time. What kind of lines are these called? What? Parallel lines. And how can we tell from the equation that they're parallel lines? Parallel lines have the same slope. Are these parallel lines? Obviously not. These are called intersecting lines. And today we're going to look at a special kind of intersecting lines that are called perpendicular lines. Now, are you familiar with the word perpendicular? Did I hear some yeses and some no's? So these lines are perpendicular lines because they cross and make a 90-degree angle. All intersecting lines are not perpendicular. Now, do you see that I have a negative slope line and a positive slope line? These lines do not have the same slope. One of them's positive and one of them's negative. What else do you notice about these slope numbers? The 3 and the 2 are switched. And so next, come on, these are perpendicular lines. They cross at a 90-degree angle right here. Do you see that one line has a positive slope and one line has a negative slope? And what else do you notice about these slope numbers? 3/4 and 4/3. Do you think we're getting a pattern here? Perpendicular lines. These cross at a 90-degree angle. One of these lines has a positive slope. One of these lines has a negative slope. One of these lines is 1/4. The other one is 4/1. What's another way to write 4/1? Just 4. So, not a bunch of examples, but do we, I think I have one more. Are these perpendicular lines? Do they cross at a 90-degree angle? A horizontal and a vertical line are perpendicular lines. This has a slope of 0. This has a slope that is undefined. A 0 slope and an undefined slope are perpendicular to each other. And this is how you write the equation for the purple line, and this is how you write the equation for the blue line. So here's where you start writing. Perpendicular lines have slopes that are opposite reciprocals. In order to tell if they're perpendicular, I have to know what the slopes are so that I can compare the slopes. So the second equation right here has to be solved for y. To solve for y, I need to add the 12x to both sides, bring this down, and divide everything by 8. And then the 12/8 has to be reduced by 4. It has to be reduced to lowest terms. This is the slope for the first one. This is the slope from the second one. In order to have perpendicular lines, I have to have opposites. Do I have, down here on my slopes, do I have one positive and one negative? Yes. Do I have flipped fractions? 2/3, 3/2. Are those flipped? Yes. My conclusion is these two lines represented by these two equations are perpendicular. In order to tell if they're perpendicular, I'm going to have to find the slope of the tables. There's 2 tables, so I'm going to have to find the slope 2 times. When you have a table you have to pick 2 points out of the table in order to use them in the slope formula. I don't need all 4 points in the slope formula. I just need 2 of the points. So, write these down and figure out the slope using the slope formula. To find the slope of a table, you use the slope formula. I have chosen to use these 2 points in the first table. 5 subtract 2 is 3. 8 subtract 2 is 6. And 3 over 6 reduces to 1/2. So you plug the numbers in the formula, subtract, reduce to lowest terms. For this table, 7 subtract 1 gives you a -8 on top. 0 subtract a -4, minus a minus makes a plus, so that's a 4 on the bottom. 4 will go into 8 2 times, that's a slope of -2. Then I need to compare slopes. I'm comparing this slope and this slope. First, do I have one that's positive and one that's negative? I have to have one positive and one negative to have parallel lines. This is 1 over 2, this is 2 over 1. Are those reciprocals? Are those flipped fractions? One positive, one negative. 1/2, the opposite of 1/2 is 2 over 1. So the conclusion that I can make is the 2 tables represent lines that are perpendicular. I'll give you a second to write that down. Now we're going to write the equation of a line that's perpendicular to this line, and it goes through this point. I can't just take the 5 out and replace it with a -7. It's a little bit more complicated than that. And so let's see what you need to do. First of all, I need to know the slope of this line. What is the slope of this line? Now I am going to make a new line, and my new line is going to be perpendicular, so I need a new slope. For my new line, I need a new slope. The slope that is perpendicular to this one, do you see that this one is positive? So my new line is going to have a negative slope because perpendicular has to have opposites. Whatever this sign on this is positive, so my new line is going to be negative. This is 1 over 3. The reciprocal would be 3 over 1. And of course, that would just reduce to -3. So I have a slope and I have a point. That's where you use your point-slope formula. When I use my point-slope formula, I fill in this and this and this. I usually start with the slope because if I know the slope already, I can't use this unless I know the slope already. And so the slope that I'm going to fill in is -3. This is an x number. X goes with x. Which one of those numbers is an x number? There's a minus from the formula and then a 1. And so the 7 goes over here. So this is a -7, and when you use this formula, this is a +7. Because this minus will be from the formula, and minus and minus will make that into a positive. And so I want to write this in slope-intercept form. If I'm going to write this in slope-intercept form, I need to do this. What does this represent? It's called the distributive property. -3x minus a minus makes a +3. I am solving for y. What am I going to do with the 7? Why did I line the 7 over here with the 3? These don't have x's, and those do not have x's. And so y equals negative 3x minus 7. This line is, it's not minus 7. Why can't I subtract? What is that supposed to be? 3 subtract 7 is minus 4. And so y equals negative 3x minus 4 is the line that's parallel to that one and goes through this point. That is not easy to do, so we need to practice again. If you didn't want to write down the whole problem, the key words are perpendicular, I need that equation, and I need that point. Those are the key words from this problem. I am going to make a new line that is perpendicular to the old line and through that point. So, I want to make a new line that is perpendicular to this one. So, what is the slope of this one? This is negative 2 over 5. So I am going to make a new line that's going to have a new slope. If this one is negative, this slope is going to be positive. If this is 2 over 5, this is going to be 5 over 2. Do you see how I get the new slope? This changes signs, the fraction flips. And then I need it to go through this point. So, the new line is going to be calculated with the point slope formula because I have a point and a slope. The slope I'm going to have is 5/2 x minus a minus 2 makes a plus 2. Minus a minus 3 makes a plus 3. The 2 goes with the x because x's go with x's. In this formula, the points change signs, not the slope, the point. So this is a positive 2 and a positive 3. Now, I have a fraction. I have two choices with the fraction. Do you want to multiply by 2 and get rid of the fraction, or distribute the fraction? We're going to go ahead and distribute the fraction, and I'll show you why. The 5/2 multiplies by the x, and the 5/2 multiplies by the 2. What happens when you have a denominator of 2 that multiplies by a number of 2? Now, I still have a fraction, but the fraction is a slope, and a lot of times our slopes are fractions. I'm solving for y. I need to get rid of the 3. Cancel. 5 subtract 3 is positive 2. This line is perpendicular to that line because this has a slope of negative 2 over 5 and this has a slope of positive 5 over 2. It is the slopes that make it perpendicular.